All right, so we've made it to chapter 2, and chapter 2 builds upon the concept we learned in chapter 1, which is all about atomic structure. And now what we're going to go into is molecular structure and concepts. Once we talk about molecules, right, we can talk about bonding. And so, a lot of the concepts in general in inorganic chemistry, you can kind of think of as accelerated or advanced inorganic chemistry. We're just going to be going into more detail than probably what you learned before. And then, later on in the course, we're building up a little bit of a stronger foundation from what you had in classes like 121 or 122 or 201 and 202, so that we can talk about uh, more advanced inorganic chemistry concepts. All right, so we're going to be first starting off with Lewis structures. Lewis structures are extremely important. It's something that chemists use, every day when thinking about research, when talking about structures. And, this gives us, it's a very simple model for the structure of molecules. It tells us information about the reactivity of molecules, tells us information through via CPR, extension of Lewis structures, the geometry of molecules, their shape, polarity. From that, we can get physical properties, right? Solubility, boiling, melting points, vapor pressure. We'll talk about bond order, single, double, triple, and others, the number of bonds in a molecule, per atom, resonance structures and calculating formal charges, how to figure out which structures are the most stable from several valid structures that could be possible, and how the electrons are distributed into a molecule. It deals with that to some extent, although as we'll see in the latter half of this chapter, molecular orbital theory does a better job actually at all of these things, but it's a little bit, it's much more complicated. Okay. So this is all about valence electrons when we're talking about bonding. Valence electrons are the ones that are involved in bonding. If a compound has a noble gas configuration, most of the time it's not going to engage in bonding. Not all the time. There are compounds. There's compounds of xenon and compounds of krypton, but those are relatively rare. Okay. So valence electrons are the outermost energy level electrons. Those are the ones involved in bonding. Here are the valence electrons in each group. Valence electrons for the d metals. We'll talk about that once we get into transition metal chemistries and how that works. But you can see hydrogen and helium are 1 and 2 respectively. And then it just goes kind of in this nice little pattern. The noble gases have 8 valence electrons. And the other elements try to make electron configurations such that they can share or transfer electrons to reach these noble gas electron configurations. So carbon is in this group here, labeled 4. So it has 4 valence electrons. Fluorine is a halogen, so it has 7 valence electrons. So Lewis bonding theory predicts how atoms are bonded together, and the dot structures are basically the symbols of this, okay? And so there are atomic structures surrounded by valence electrons, and one dot represents an electron. So as an example, you can look at oxygen. We know what the electron configuration of oxygen is. It's 1s2, 2s2, 2p4. This has 6 valence electrons because we're talking about the n equals 2 here. Those are the outermost electrons. We don't care about the n equals 1. We call those core electrons, the 2 electrons there. So 6 valence electrons. 2 happen to be in the 2s, 2 happen to be in the 2p. But you sort of forget about 2s and 2p when you go into this Lewis structure space. So what you do is you just keep adding electrons. So we have 6 valence electrons, and you add them singly, and then pair them up. So 2 electrons, dots per side, and write them singly, and then double them up. That is the convention. So noble gas configurations, those are the same electron configuration as a noble gas. That means 8 valence electrons. We talked about the spectral lines of the elements and how those are different. With noble gases, it's very easy to do these experiments because they're gases at room temperature. So you can just put them in a tube that doesn't have any other gases in it. So usually you pull a vacuum on it first. And then you introduce a small quantity of that gas, you apply high voltage, and you get these beautiful colors. You're familiar with these, right? Neon sign. That's how neon signs work. Sometimes you'll see other colored signs. They have other elements in there, or they could be pure elements. So that's so noble gas configurations. you want 8 valence electrons, and this is where you get into the octet rules, which, I will point out there are a lot of exceptions to the octet rule. We'll go over some of those. So you can kind of think of these as octet guidelines. But we'll dive deeper into the octet rule and doing some problems on those in the next video.